Question number 22. What is the value of del to the power 5 1 upon x at x equals to 2? Take the interval of differentiating to be unity. So we know that delta fx is equals to f x plus 1 minus fx when the interval of differentiating is unity, that is h equals to 1. Right? So there are three methods. First, talk about the basic method. So if we are using delta square fx, we have to operate delta first, then again delta, like this one. So this will give us fx plus 1 minus fx. Then again we have to use delta on both of these functions. Delta fx plus 1 minus delta fx. So from here we will get fx plus 2 minus fx plus 1. Then from here we will get fx plus 1 minus fx. So if we remove the bracket, we will get minus 2 fx plus 1 minus fx, sorry, plus fx. In this way we can use this delta definition. So if we want to apply this definition on the given question, how can we proceed? If we have delta to the power 5, on the place of fx we have 1 upon x, then we can write it as delta to the power 4, then delta 1 upon x. So if we operate delta on 1 upon x, we write it 1 upon x plus 1 minus 1 upon x. Then again we can write it as delta to the power 3, then delta on both of these functions, x plus 1 and 1 upon x. Now we have to operate the delta again. If we operate delta on this function, we get 1 upon x plus 2 minus 1 upon x plus 1. And if we operate this delta on this function, we get 1 upon x plus 1 minus 1 upon x, like this. We have to solve it till we utilize all the powers of delta. What is the another method? In the last we will put x equals to 2 and we can solve it to get the answer. What is the second method? Second method is to change the delta in the powers of e. We know that this delta is equals to e minus 1. So on the place of delta to the power 5, we can use e minus 1 to the power 5. So instead of operating this uh, delta on 1 upon x, we can just take the 5 power of e minus 1. Then what we can use, we have the property e fx equals to f x plus 1. Means whatever power is e have, we have to add that one in the x in the function of f. If we have e to the power 2, that will be equals to f x plus 2. If we have e to the power 5, we have to write f x plus 5. Like this we can use this property also. Now what is the third method? Third method is the utilizing the formula of delta to the power n fx. Now here we are assuming the interval of differentiating h equals to 1. Okay. So what is the formula? Formula is that summation k going from 0 to n minus 1 to the power n minus k, nck, this is the combination, n choose k, and then f x plus k. But we know that remembering all the formulas in numerical analysis is very hard. So what we can do for these kind of questions, we can use a trick to solve these kind of questions. What is the trick? The trick is that we are given delta to the power 5 1 upon x. Here fx is 1 upon x and the value of n is 5. So we need to remember two, three things before solving the question further. The first thing is that if we have power 5 here, then we will have total 6 terms in the solution. If we have power 10 of delta, then we will have 11 terms in the solution. Likewise, if we have power n, then we will have total n plus 1 terms. Second thing is that we have to look at the power of delta. If the power of delta is odd, then we have to start our solution with a negative sign. Then we will use alternate sign. First sign will be negative, then plus minus like this one. If we have power of delta is even, then we have to start from plus. Then we will use minus, then plus, then minus like this one. We can proceed. So here we have delta to the power 5 which is odd. So in total we will have 6 terms and the terms will start with a negative sign because delta to the power 5 is a odd number. So we will put a negative sign first of all. Now we have to calculate NCK starting from k equals to 0. So value of n is 5 and we have to start from k equals to 0. 5c0, this will be 1. So this will be 1. Multiply by whatever function is given, just write it at it, add it is. Now we have used minus sign here, so we will use plus sign here. Now we have to calculate 5c1. 5c1 will be 5. 5. Multiply. Now we have here 1 upon x. Just add 1 to the x. So in the function fx, wherever we have x, just add 1 to the x. Now the negative sign, we have to calculate 5c2. This will be 10. 10 into 1 upon x, 1 upon x plus 1, then we will have 1 upon x plus 2. We have to write 6 terms in total. Why? Because the power is 5. Then we have to use plus. We calculate 5c3. That will also be 10. 10 into, now we have to add one more, x plus 3. Then minus sign, 5c4. 5c4 will be 5. 5 multiply 1 upon x plus 4. So we have written total 5 terms, but there should be 6 terms. Then in the last term we will add plus, then 5c5. 5c5 will be 1 into 1 upon x plus 5. Finally we get minus 1 upon x plus 5 upon x plus 1 minus 10 upon x plus 2 plus 10 upon x plus 3 minus 5 upon x plus 4 plus 1 upon x plus 5. Now we are asked to find the value at x equals to 2. So on the place of x, put 2. 1 upon 2 plus 5 upon 3 minus 10 upon 5 plus 10 upon, sorry, this will be 4. 5 minus 5 upon 6 plus 1 upon 7. Now we can take minus 1 by 2, then this term will be minus 2.5, then this term will be 2. Then we will have plus 5 by 3, then minus 5 by 6, then 1 plus 1 upon 7. So from here we will get minus 1 from these things, then plus 5 by 3 minus 5 by 6 plus 1 upon 7. If you take LCM will be 42. So we will get minus 42 plus 70 minus 35 plus 6. In total we will get minus 77 and plus 76 upon 42. So this will give us minus 1 upon 42. Option D will be correct. Again, whatever method we have studied here, we can take another example to understand this method. Let us take another example. Suppose we want to find value of delta to the power 4 1 upon 1 plus x square. Now here the function fx is 1 upon 1 plus x square. So in the function we have x here. So wherever we have x, we will add 1, 2, 3 in the x and proceed to the next term. Now first thing is that delta to the power is 4. So there will be 5 terms in total. The second thing is that the power is even. So we will start with a positive sign. And third thing is that we have to keep increasing 1 with the x in the function of x. So we will start with positive sign. Then we will calculate 4c0. This will be 1. So 1 upon, then we have to write the function as it is. Then negative. Then we have to calculate 4c1. 4c1 will be 4. So we will get 4 upon. Now we have to increase 1 on the place of x. So we have to add 1 on the x and take 2, power 2. Then using alternative sign, we will get plus here. Then we have calculate 4c2. This will give us 4 factorial, 2 factorial, 2 factorial. That will be 4 into 3 upon 2. That will be 6. 6 upon 1 plus x plus 2 square. Then negative sign. Here power 4. So there should be 5 terms. 1, 2, 3, 4. 4 term will be 4c3 and that will be 4. So we have 4 upon 1 plus x plus 3 square. Then positive sign. In the last we have 4c1, 4c4, that will be 1. 1 upon 1 plus x plus 4 square. Now we can solve it and put x equals to 2 or 3, whatever is given in the question. So this is the method to use the formula delta to the power n f of x equals to summation k going from 0 to n minus 1 to the power n minus k n c k f x plus k.